Hello everyone, welcome to a problem season 2 of vector and kinematics series. So till now we have discussed the generalized expression for velocity and acceleration for any kind of zigzag motion and or any non-uniform circular motion. So we'll apply that formalism to the few problem here that we are going to discuss. So the first thing is to remember the expression for velocity and acceleration for this kind of motion. So that is that we have already derived earlier. That expression for b is just r dot r cap plus r theta dot theta cap, and a is just r double dot minus r theta dot square r cap plus r theta double dot plus 2 r dot theta cap. So we'll use these two expression, these two generalized expression for deriving the expression for velocity and acceleration in for any zigzag motion. The first problem is here. You have a bead that moves along the spoke of the following wheel at a constant speed u, and the wheel rotates with the uniform velocity omega. It has been also given that t equals to 0. The particle, the bead was here at the origin, and the spoke is along the x-axis, and then you need to find the bead's velocity at any later time t in polar coordinate and in Cartesian coordinate, and you will see that how much simple the problem is in polar coordinate rather than in Cartesian coordinate after that. So then the from in the second problem, in the second part, you need to find the bead's acceleration at any time, at any instant of time. So here the r at time 0 at t equals to 0 is 0, right, since it was at the origin. Now our radial velocity, that is dr by dt, that is u. Where r is 0, that means the radial part, that is r and theta, they are both 0, right? Since the bead is here, its radial part is 0, and the theta part is also 0 at t equals to 0. So now dr by dt is u dt. So what is r? R is nothing but u dt. So if you integrate this expression, so at t equals to 0, r was 0 from here, this condition, and at a later time t, let's say the position is r, and u I have pulled outside because u is just a constant. So here r is just ut. In the similar case, since theta was 0 and it has been given also d theta by dt is omega, so using the similar logic for as we have applied for r, the radial motion, so theta is also omega t, since theta is 0 at time t equals to 0. So our r is ut and theta is omega t, and also r dot is u and theta dot is omega. Now what is the our now next thing is what is we need to determine the velocity. So velocity from this earlier expression, that v is r dot r cap plus r theta dot theta cap. So we know r dot is u, so it is just u r cap, and what is r? R is just ut, we have already derived. So r is ut, and what is theta dot? Theta dot is omega, so ut omega theta cap. So what? So our velocity v is just u r cap plus u omega t theta cap. So this is the expression for velocity. So now this is our answer to part 1a. Now it's part 1b. In part 1b, we need to find the same thing, Cartesian coordinate. So for this, let's say the better way is to that here we have the expression for Vr and b theta, that is Vr is just u and b theta is u omega t. So the smart strategy is to determine the Vx and Vy as a function of Vr and b theta. So that is the easier thing to deal with. So let's say that's a defined function, that is g. So if we need a transformation rule for computing Vx and Vy in terms of Vr and b theta. So how? So this is let's draw our axis, that is that is our x-axis and this is y-axis. Let's say the particle at an instant of that beat at an instant of time is here and it makes an angle theta. Then this is the direction of Vr and this is the direction of b theta and this is the direction of, let's say, minus of b theta. So this is the direction of minus of b theta and this is the direction of minus of Vr. So now what is our Vx and Vy? So this is the direction of Vx and this is the direction of Vy. So if this angle is theta, then this angle is also theta, since this and this is parallel, and since this plus this is 90 degree and this plus this is 90 degree, so then this and this angle, they are equal. Then this is also, that angle is also theta. So now the one part of here, important thing to note that the one part of Vx acts along this direction, another part of Vx acts along this direction. So what is now Vx? So Vx is Vr cos theta plus minus b theta sin theta. Since theta is closer to Vr, so then it will be cos theta. The part that is closer to Vr, that will be cos theta, and that is in the perpendicular direction, that will be sin theta. So this is the rule. So the Vx is just now Vr cos theta minus b theta sin theta. Then what about Vy? Here, so Vy, one part of Vy acts along this and another part is along this, but both the components are positive here. So what is Vy? Vy is nothing but b theta cos theta plus Vr sin theta, right? So now let's express it. So now we have expressed the Vx and Vy as a function of theta and Vr and b theta. So we already know that Vr is u and b theta is u omega t. So we have obtained Vr is u and b theta is u omega t. Now what is Vx? Vx is u cos omega t minus b theta u omega t sin omega t. Since theta is omega t, we have derived it right there. So again, what is Vy? Vy is b theta is u omega t cos theta, that is cos omega t, plus what is Vr? Vr is u sin theta and then sin omega t. So that are the Br and Bx and By as a function of theta, omega and u. So our B is nothing but now Bx x cap plus By y cap. So this is our answer to part 1b. So we have realized, so it's just one line process in polar coordinate, but we have to do lots of stuff in while getting the result in Cartesian coordinate. So in this kind of non-uniform circular motion where the bead is moving in a radius varying in a circle where radius is also varying, this is a non-uniform circular motion, it is easier to choose polar coordinate rather than choosing the Cartesian coordinate. So now in the next thing we need to find the bead's acceleration. So how do you find that? So in order to find that, we have already the, so this is just problem 2, 1.2, whatever. So bead's acceleration, the expression for acceleration is given as r double dot minus r theta dot square r cap plus r dot theta dot plus 2 r dot theta dot, sorry, r theta double dot, what am, this is mistake, r theta double dot plus 2 r dot theta cap. But here r is ut and theta is omega t, u and omega are constant. Definitely r double dot is 0 since r dot is u, theta dot is omega, and r double dot is definitely 0 since u is constant, and similarly theta double dot is also 0. Now what remains is just our, so if you apply these conditions here in the expression for acceleration, you will get minus r is just omega ut, so r is ut omega square r cap plus r theta double dot is 0, so plus 2 r dot theta dot, that is 2 u and omega theta cap. So that is the expression for acceleration is just u omega square t r cap plus 2 u omega theta cap. So this is the expression for acceleration. Now let us plot the trajectory of the particle as a function of time. So it is important to note that Vr is u and V theta is u omega t. So that is, as t increases, Vr will remain constant. But what about V theta? It will increase over time since V theta is linearly proportional to time. So let us take the coordinate to be x and y. So let's say at theta equals to, let's say at pi by 6, let's say the particle is here, and initially Vr will be larger than V theta. So let's say this is let's say Vr, this is let's say V theta, so the velocity will be inclined towards Vr. Let's say at theta 5 by 3, they both become equal. Let's say this angle is pi by 3, then the so as t increases, since r is ut, so r will also increase. So initially the particle also is here, then it will be in slightly larger position, let's say here. At here our that Vr and let's say V theta, they both equalize such that the angle is at 45, this angle is 45 degree, they both equalize. Let's say at at let's say 90, the particle will be let's say here. Again the radius will increase here. uh, then the b theta will be along this direction. It will be larger, and this is the direction of let's say Vr. It will be remain constant such that the velocity is inclined towards b theta. So this is the case. Now let's say at theta, this is at theta pi by 2. So let's say at theta, let's say take any angle, let's say 3 pi by 4. So this angle is 3 pi by 4. In this case, the r will also increase, and the b theta will be much larger than Vr, so it will be more inclined towards b theta, the b. So the trajectory will look something like this. It will start from the origin, go all the way up to here, then here, then up to, this will be like this. It will be following this kind of trajectory. So this is the case. So this is the trajectory. So this is the answer to our problem. So in the second problem, we have another complicated situation where the r is a function of time such that the radial velocity is not constant. So this is the more complicated scenario than the earlier case. So in this case, the important consequence is that for a certain values of that beta, where r is r naught e to the power beta t, you will see that the particle moves with the without any acceleration in radial direction. But this is unexpected, right? Since r is e to the r naught e to the power r naught e to the power beta t, then what is r dot? R dot is r naught beta e to the power beta t. What is r double dot is r naught beta square e to the power beta t, right? So it has some part, but it has been given there for a certain values of beta, the particle moves with ar equals to 0. So this may be unreasoning from this point of scenario, but this is the case. So how? So now, what is a we already know, the expression you already know, that is r double dot minus r theta dot square r cap plus r theta double dot plus 2r dot theta cap, right? So what is r double dot? So r double dot is r dot beta square e to the power beta t minus what is r is r naught e to the power beta t theta dot square. So what is theta dot? Theta dot is, again as our earlier case, theta dot is constant, but so here r dot e to the power beta t and theta dot square is just omega square, and then it is r cap, and theta double dot is 0 anyway since omega is constant, plus 2 r dot beta e to the power beta t, and theta dot is omega theta cap. So this term is subtracted from this term, so it may be possible that this can go to 0, but this is not anyway 0, because even if at t equals to 0, it is 2 r naught beta. So the theta part, so a theta part will never go to 0, but the r part can go to ar part can go to 0. That means our beta square e to the power beta t minus r naught e to the power beta t omega square is 0. So that is so this is the case. So sorry, these are not here. So just omega beta square, this means beta square minus omega square is 0. That means omega is plus minus beta. So in the case of omega plus minus beta, the air part will go to 0. So it is very surprising at first that when r is a exponential function of time, the particle moves with the zero radial acceleration, right? The error in thinking is that the r double dot makes the only contribution. That is, we have earlier thought the r double dot makes the only contribution to the acceleration, but here the another part, the counterpart, that is r theta dot square, that part it is being subtracted in original case. So these two part actually makes the both their both subtraction makes the total contribution. That's why, so there the radial part can go to 0, but the tangential part in this case will never go to 0. So that's the thing. So it is important to note that in Cartesian, in polar coordinate, unlike in the case of Cartesian coordinate, Vr is never equals to that AR t dt, right? So that's the thing. So in this case, that Vr, and that is the r dot, so that is r naught omega e to the power beta t, that is increasing rapidly with time. So that's the case here in polar coordinate, that Vr is never equals to that ARTT. So because AR is this thing, so if you make the if you take the integration with respect to time, if it is only r double dot, then and this case is valid. So then if Vr is only r double dot, then Vr can be written as ART dt. But for any generalized case where Vr where AR is r double dot, then Vr is ART dt, right? But if AR is not r double dot, that is in generalized case, AR is not equals to r double dot, that is r double dot minus r theta dot square, that is AR is r double dot minus r theta dot square. In this case, this thing is not valid. So that's why the radial part can go to 0. So that is our answer to the problem B, problem 2. So that's it for now. Thank you.